Yes, welcome back to our class. That is Ajay Kumar Yadav, and we are back in live now to discuss about the next concept of our class. That is nothing but accelerated motion of an body. So, accelerated motion of an body can be explained by means of an diagram also. But let us start with the equation, and that is the most prominent one. So, we are going to discuss about the four equations of motions today. Let me give you the clarity what are the concepts we are going to discuss in our today's class. So four equations of motion. As we know very well, mostly people used to say it is said to be S3, but we would like to go ahead with the 4 is the one extra one. So for the first one, we would like to go ahead with V is equals to U plus AT. Next, second one, we would like to go ahead with S is equals to ut plus half times of at square. Then, third equation of motion, we can name it as v square minus u square is equals to 2as. And at the last, we can say that Sn is equals to Snth is equals to Snth is equals to u plus a by 2 into 2n minus 1. So today's session we are going to discuss about all the four equations for our today's session. And let me give you clarity on this. First we have to begin with the formulas. There are various such formulas have been highlighted there. You can highlight from the basic equation that is called as the equation of motion, and even you can draw the some line and explain that concept. So we can start with the this graphical representation. We'll say this is my 0. I can say this is my initial velocity considered as u, and this is my final velocity which is considered as v. So as I represent here, we can say initial velocity position as x0 and this position as x1. So this represents the position. This represents the position. This represents the initial velocity. Okay, and this equation represents the final velocity. I hope you will be very clear. With this diagram, we can able to even elaborately speak about the next concept, that is first equation of the motion. So let me start with the first equation of motion. Here you can say that time t is equals to 0. Here you can say times t equal to 0 or time t is equals to maximum t. Even you can represent the t also. Okay, next. So let me begin with the basic concept today by writing the formula as acceleration. Let me give you brief elaboration about this. Acceleration is equals to change in velocity. Change in velocity. Change in velocity divided by time taken. Acceleration is equals to change in velocity divided by the time taken. Okay. We can also write in the form of abbreviation a is equals to v minus u by t. So if we go for a cross multiplication like a into t is equals to v minus u, or we can write it as u plus at is equals to v. U plus at is equals to v. This is also called as the this is also called as the this is also called as velocity time relation. It is also called as the velocity time relation. I hope you will be very clear. Velocity time relation. And the next point we are going to discuss is nothing but the velocity time relation. That's all about this first equation of motion, which is also called as the first part. Next, we are going to discuss about the second part in our today's session. Let us see the second part today. Second one, we have to understand with a very basic concept by writing the formula. So as we know very well that V average is equals to displacement by time. You know what is V average? V average is equals to displacement by time. So we can also write it like, sir, V average is equals to x minus x naught or divided by t minus t naught. So where t naught is considered as 0. So we can write it as nothing but V average is equals to x minus x naught divided by t minus 0. So at last the equation is V average into 2. V average can also be written as V average into t is equals to x minus x naught. In this sense also we can able to define the equation. Next we are going to talk about the next point of the discussion goes is nothing but the V average. Sir, how would you represent the V average? V average means what? Initial plus finals. So final plus initial divided by 2 into t is equals to x minus x naught. In this sense also you can represent the equation very perfectly. I hope you would be very clear. In this part, if we would like to do some little changes, we know very well that what is the first equation of motion here. The substitute first equation of motion into the second part. So instead of v you substitute this value there. So how would you like to go ahead with the value? So u plus at plus u divided by 2 into t is equals to x minus x naught. I hope you would understand better. So if I want to remove the bracket, I can write it as 2 times of u plus at divided by 2 into t is equals to x minus x naught, and most obviously you know very well 2ut plus at square by 2. So if you divide this term, you will end up with the very favorite equation, that is second equation of the motion. You'll end up with the very favorite equation, that is second equation of the motion there. So we can write second equation of motion as ut plus half times of at square is equals to x minus x naught. So x minus x naught is equals to u plus at. This x minus x naught can also be written like ut plus half times of at square is equals to s. So how would we call this equation, sir? And what do we name this equation there? This equation will be called as the relation between. I'll write it here. Relation with position and the time. Relation with the position as well as the time. And the second part, which equation relates the relation with distance and time. Relation is distance and time. So the required relation will be considered as position time relation, and the required relation will be called as the distance time relation. This is called as position time relation, and this is called as distance time relation, and which is also called as the second equation of the motion there. So I hope you would be better understanding now regarding the second equation of the motion there. Now we would like to go ahead with the third equation of motion. Let us begin with the third equation of motion there. So how do we speak about the third equation of motion? In the third equation of motion, we should suppose to start with the same relation, that is nothing but the velocity at a certain position, which is called as the same formula I have to write there. Sir, how would you represent the formula there? We have seen the formula there, that is nothing but the V average is equals to displacement by time, as we know very well. V average is equals to displacement by time. So V average is equals to displacement divided by the time. Correct? I hope now you would be very clear. So V average is equals to, we can write it as x minus x naught. Displacement is considered as x minus x naught. We have discussed in the previous equation. X minus x naught divided by t minus 0, and we will write it as V average into time is equals to x minus x naught. We can also write it here, instead of V average here we have written the equation as V plus U. V plus U divided by 2 into T is equals to x minus x naught. So far we have learned in this equation is this terminology. Now I would like to go ahead with the small changes. Here I would like to go ahead with the time. Now I will consider substitute the value of time. Substitute the value of time from equation 1. Sir, what is the value of time? V is equals to u plus at. You can write it as v minus u by a is equals to t. I hope you will simplify this equation. I will substitute into that. So substitute this equation into this place. Substitute this equation into the time place. U will remain as it is onto the time place. So we can write it as v plus u by 2 into v minus u by a is equals to x minus x naught. Is equals to x minus x naught. We can also write it as, the equation is looking like a square minus b square is equals to a square minus b square is equals to a plus b and a minus b. So we'll follow this equation as v square minus u square divided by 2 into a is equals to x minus x naught. We can write it here as v square minus u square is equals to 2 times of a x minus x naught. This equation is also applicable there. This equation is also applicable there. In the other sense, you can write the next set of the equation, that is considered as the v square minus u square is equals to 2 times of a into s. Sir, what do we call this equation? This equation will be called as the third equation of motion, and this equation is the required relation between velocity and the distance. So this is the relation between velocity as well as the distance. Velocity as well as distance. The third equation is velocity as well as the distance, and this equation which you have seen at the last, and this is the required relation. This is the required relation. This is the required relation for the velocity position. Velocity as well as the position. Velocity position. Velocity position relation. This is how we are supposed to write it for the third equation of the motion. Now we would like to go ahead with the equation number 4, that is distance covered in the nth second. The topic will be distance covered in the nth second. Distance covered in the nth second. So let us see with a diagrammatical representation so that we can understand the concept very clearly. We will try to draw with a small line. In this line, we would say that here time is considered as 0. Here I will consider as the time t is equals to n. Okay, this is the basic understanding we need to understand. So for work is done from 0 to n. Work is done from 0 to n. So if I draw the line in between like this, so this is called as the t is equals to n minus 1. Some distance we will consider. This is n minus 1. So between these two distance, how will we call the displacement? And between these distances, how would we name them as the displacement? So we would like to go ahead with the s is equals to this distance will be called as the Sn minus 1, and this distance will be called as the Sn. So our basic understanding goes for the distance covered in the nth second will be Sn minus 1 and to the Sn. So let us start this equation with our next formula, that is nothing but the distance traveled in the t second. So let us write these sentences very clearly so that we can derive the equation. Distance traveled in n second. Distance traveled in n seconds. Distance traveled in nth second, that is nothing, t seconds, sorry. Distance travels in the t seconds, that is s is equals to ut plus half times of at square. Okay, so we can write this in the form of an t seconds. Now the second one goes to the distance traveled in the n minus 1 seconds. N minus 1 seconds. So how would we like to name the equation? So s of n minus 1 is equals to u of n minus 1 plus half times of a into n minus 1 the whole square. Next, the very next term we would like to start up with the distance traveled for n seconds. Distance traveled in first n seconds. First n seconds. So how would you name this first n seconds? We would like to start up with the next part. The equation stands there is Sn is equals to u of n plus half times of a of n square. Next, hence the distance traveled in the n second is. Now the equation we have to define here. Hence the distance traveled in n seconds. Distance traveled in nth second we can say, rather than n seconds we will say nth second is. How would we name them? S nth is equals to s of n minus s of n minus 1. S of nth is equals to s of n minus s of n minus 1. Now we will go with the derivation part. We will substitute the values there and we'll write the equation again so that for better understanding we'll go ahead with that. So s of nth is equals to s of n minus s of n minus 1. So what is s of n is equals to u of n minus half times of a of n square. I hope you would be very clear with this point. Minus times of u times of n minus 1 plus times of half times of u n minus 1 the whole square. This paragraph is also very clear. So shall we start with the derivation part? Yes. Un minus half times of an square. First multiply inside. Minus times of un minus of u. Still keep the bracket there. Don't open the bracket. Plus times of half times of u n square minus 2n plus 1 square. Correct? Plus 1 square. Am I right? So still we can derive this equation. We are into the track. Un minus half times of an square minus times of, don't remove the bracket still, un minus u plus half times of un square minus 2un plus this will be considered as the a. Instead of we are writing here as a, so we should substitute the value here as a. So it is nothing but a square divided by 2. A square divided by 2. Now we can take the bracket. First one inside, second one inside, third one, fourth one, and followed by fifth one. So this is how we have to insert the minus sign inside the equation. Half times of an square minus un plus u. Clear? Minus minus will become plus. Minus times of half times of an square will be plus times of 2an and minus times of a square by 2. The whole bracket is becoming one single bracket. Now we have to substitute the values. Sir, this is plus term, this is minus term. Cancel it properly. Next, sir, this is minus term, this is also obviously it will come as an plus only. I mistaken there, it is plus only. Sir, here also it is considered as here it is obviously plus. Sorry. Here it is obviously plus. And here it is obviously minus. Here it is obviously minus there. So this plus symbol and this minus symbol will cancel out. So my required term will be u times of plus 2an minus a square by 2. This is the required term we had got derived from the equation. Now I have to write it here as u times of a divided by 2a 2n minus 1. This is how I will get the equation, the final equation to define the nth term. Nth term of the equation. So we will go ahead. So we would like to go ahead with the brief summary part related to the equation. As we know very well, we are going to define the three equations and the fourth one will be the complementary one. So the accelerated motion of an body, very first equation is s is equals to u plus at, that is v is equals to u plus at, s is equals to ut plus half at square, v square minus u square equal to 2as, and nth equation is equals to u plus a by 2, 2n minus 1. We have started this equation acceleration equal to change in velocity by time, and we have derived the equation. This relation is also called as velocity time relation, which is very crucial point. Next we have to do, in seconds we will move on to the next derivation part, that is nothing but v average is equals to displacement by time. V average is equals to x minus x naught t minus t naught, and we'll substitute the value of v average. So after simplification it will goes to the final touch up, and the final equation will stand here is nothing but ut plus half times of at square x minus x naught, or s is equals to ut plus half at square. One is called distance in the position time relation and the distance time relation. Next we would like to go ahead with the third equation of motion, that is nothing but the third equation of motion. Same equation we have to use here, but we have to do the small changes to the time, and the time we are going to represent here as from the help of first equation v minus u by a. So we will also write it as v square minus u square divided by 2a is equals to x minus x naught, or else we can write it as the v square minus u square equal to 2as. What is this relation is called as velocity distance relation. Then what is this relation will be called as velocity position relation. And at the last we have to define the fourth equation, complementary one, t equal to 0, t equal to n. If I go with the before value of anything lesser than the n, tn minus 1, then this tn minus 1 will be called as snth value, sn minus 1 value, and this is sn value. And we would like to say that after the explanation, regular explanation of this part, Sn value, Snth value, St value, this is the St value. Then we will go ahead with the Snth value which we have defined, and Snth value will be Sn minus 1. And at last, if after derivation, so this is the derivation part we have started with, and we have landed with the exact equation, that is u plus a by 2 2n minus 1. So we have derived the four different equations for the session, that is 2a, yes, v is equals to u plus at, s equal to ut plus half at square, v minus, third equation is v minus e square equal to u square plus 2as, and the fourth equation will be snth is equals to u plus a minus 1, a by 2 2n minus 1. That's all about the today's class, and that's all about the today's session. Hope you will meet with the next concept very earlier. Thank you very much. Don't forget to subscribe and like our channel. Thanks a lot.